situation. So today we will discuss about the equilibrium of the bodies. Okay, so equilibrium. Okay. So what exactly equilibrium means? Suppose there is a body, there is an object. So what will happen if you apply some force over here? So it will move. This is what translatory motion. Translatory motion. Okay. Instead of that one, we will think that if I apply force over here, the body may not move, but then also body will move. So instead of moving in a translatory, so it will take the rotatory motion. Rotatory, it is rotating. Along with rotation, it is moving also. That will become what rotation and translation. Okay, translatory and rotatory, both. Okay, so anywhere you can apply the force, that force will show some effect. Okay, so if this is the case, instead of one or two forces, if so many forces acting on the body, suppose a force will act on this side and force will act from this side, force may act from this side, force may act from this side. When so many forces act, F1, F2, F3, F4, so what will happen? The effect of all these forces may compensate. It depends. It depends on what are the values of forces. But sometimes when so many forces acting, on an object, the effect may compensate. Okay, see, the effect of forces may compensate each other. Okay, so when they compensate each other, so what will happen? There is no net force on the G. When the forces get compensated, F net will become what? F net will become 0. As we know that from the second law, if F net is 0, acceleration is 0. That means it will not produce any acceleration, that will not produce any moment. Okay, so when net external force is 0, obviously the forces get cancelled and acceleration is 0. That means body will not change its state of rest or motion. Okay, so if this is the case, then body will not change its state of rest or motion. It will not change its state of rest or motion. If body will not change its state of rest or motion, even though so many forces are acting, then body is said to be in equilibrium. I hope you are getting what exactly equilibrium means. Forces are acting, but F net is 0, means body is not changing its state of rest or its state of motion. Then what we can say, it is in equilibrium. And it doesn't mean that equilibrium is only at rest. It doesn't mean that equilibrium means it is only at rest. It may be moving also. So that is why there are two types of equilibrium. What are that? What are those? That is what the first one is static equilibrium. Static equilibrium. Okay. So next is dynamic equilibrium. Static and dynamic equilibrium. Okay. So there are two types of equilibrium. One is static equilibrium, dynamic equilibrium. Static equilibrium, what will happen? In this case, F net will become 0. Okay. So applied, the total resultant force is 0. But what will happen? Body is at rest. This kind of situation we call it as static equilibrium. Then what about the dynamic equilibrium? Dynamic equilibrium, obviously F net is equal to 0, but body is moving with with constant velocity. With constant velocity. That means what? It is in uniform motion. It is with a uniform velocity, you can say. So that is why this is called as what? Dynamic equilibrium. That means body is moving with some constant velocity. Of course, forces acting from this side also, forces acting from this side also, forces get cancelled each other. That will not affect the motion of this object. Okay. So this kind of situation we call it as dynamic equilibrium. Here what will happen? Forces act from both the sides, and that make the body to comes to the rest, and it will not allow body to move. That kind of equilibrium we call it as what? We call it as static equilibrium. Okay. So let me write a general definition of equilibrium. Let me write a general definition of equilibrium. A particle or body. A particle is said to be in equilibrium. If particle does not change, or if it does not change, if particle does not change its state of rest or motion, if its state of rest or motion, in absence of any net external force. That means unless an external force acts on that one, it will not change. Or even though forces are acting, if net external force is zero, if net external force is zero, this is what vector sum of forces is zero. If this is the situation, then the body is said to be what? Body is said to be in equilibrium. Okay. So for body to be in equilibrium, what is the condition? The condition is vector sum is equals to zero. Vector sum of forces 0. So that means if there is a body, so some F1 force is acting in this direction and F2 force is acting in this direction. Okay. So if it is in equilibrium, if it is in equilibrium, so what is the condition? Sum of forces is 0. Sum of forces is 0. Okay. So summation of F equals 0. What is sum of forces? F1 plus F2 equals to 0. So that means F1 is equals to what? F1 is equals to F2. Okay. So if these two forces are equal and opposite, so obviously body is in what? Body is at rest, or it is continues to be in the state of uniform motion. So that is why. So this condition is true. Or suppose instead of this one, if there are three forces acting on an object. Suppose one force is in this direction, another force is here, and this is here. Okay, so this is what F1, we can say F2, and this is F3, and this is what F1. Okay, so now if this is the case, so then what is the vector sum of these three? How we can find the sum of these three? You have to take resultant of these two, because I want something over here. Okay. So how we can get this one? So from your parallelogram you can draw over here. Okay. So this is going to be a vector. Okay. So from tail to head, and this is what resultant. So if this is F2, so this is F1. So I am just applying your triangle or parallelogram now. Okay. So this will become what? This is resultant of these two. So this is nothing but F1 plus F2. Okay, so F1 plus F2 are what? They are equal and opposite. Suppose an object here or particle here is going to be in equilibrium for we can take object A to be equilibrium. Okay, so what is required? These two forces equal and opposite. So these two forces should be equal and opposite. Now you forget about this one. You have taken resultant over here. What we got like this now. This is what A, and here this is what F1. This will become F1 plus F2 plus F3. Okay, so now F1 should be equals to what? F1 should be equals to equal and opposite to F2 plus F3. Okay, So these are what vectors. Obviously, if these two are equal and opposite, this is going to be what, this particle A is going to be at rest. So you take this on this F2 plus F2 plus F3 on this side, so that will become what, F1. So this negative will become positive, plus F2 plus F3 equals to 0. Okay. So what we got condition is F1 plus F2, sorry, summation of Fi, you can write summation of Fi equals to 0. Okay. So similarly, if there are suppose n number of forces, if there are n number of forces, so what you can write, suppose the forces are like this. This is what F1, this is what F2, here somewhere F3, here somewhere F4, so on like, somewhere it is coming to what, Fn. If there are n number of forces, then also you can write it as F1 plus F2 plus F3 plus so on like plus Fn equals to 0. That means sum of all the forces should be 0 if you want a body to be in equilibrium. So what you can write? You can write summation of Fi. So I start from 1 to n equals to 0. That means vector sum of all the f's should be equals to what? Should be equals to 0. And this means what? This F1 plus F2 plus F3, F1 plus F2 plus F3 equals to 0. It also gives another very important equation, that is what? Their components also should be equals to 0. Sum of their components also should be equals to 0. What is that? Suppose if you take its components as F1x and its x component is F2x and its x component is F3x equals to 0. Okay. So similarly, F1y plus F2y plus F3y should be equals to 0. So similarly, F1z plus F2z plus F3z should be equals to what? Should be equals to 0. That means what I am writing is summation of Fx equals to 0, summation of Fy equals to 0, summation of Fz equals to 0. That means when you resolve something, their sum is also should be what? That sum is also should be equals to 0. Their components. Suppose if you take some f over here, so this is what x, y, z axis. Okay, x axis minus x, y, so minus. Okay, so if this is the force, so this is F1 and another force here you can take it as F2. Then sum of their x component should be equals to 0. That means what is its x component? Fx equals to F1. If this is theta, F1 instead of writing you can simply write its x component is what? F1x and its y component is what? F1y. Similarly for this one, its x component is what? X component is F2y and F2y and its y component is F2y and this is what? F2x. Okay, so that means their individual sum of components also, that is F1x plus F2x should be 0 or F1y plus F2y should be 0. Then only what we can say? You can say a body is in equilibrium. Okay, so this is what alternative. But in general, you can say sum of forces should be 0. When there are many forces, then we have to go with the components. That we'll see when we solve the problems. That you can understand that one in next example. So let me take that three forces and we will check how we can make components is equals to 0. Okay, so this is what? X minus x, y, so minus y. So here one force is acting, call it as F1. Here another force is acting, call it as F2. And here one more force is acting. So F3. If a body here is at equilibrium, we will check how we can make sum of components to be 0. Okay, so say this is making an angle of say alpha and this is making an angle say beta or theta 1, theta 2, whatever you can take. So x components we have to find. What is the x component of f1. X component of f1 is f1 cos alpha. Yes, or f1 cos alpha. This is what? This is fx or f1x. Okay. So similarly, its y component is what? Its y component is f1 sin alpha. F1 sin alpha. Similarly, this side, f2x component is what? F2 cos alpha. F2 cos alpha. And what about this one? This is what? F2 sin alpha. Okay. So, but it is along the negative, so we can take it as minus F2 cos alpha. So here F3 is there as it is, so no need to take its components. So now sum of x components to be 0. Sum of x components to be 0. That is fx. Sum of fx to be 0. Fx is 0 means what we have to write? So f1 cos alpha. F1 cos alpha, and what is f2x? F2x is, or I can write f1x plus f2x is equals to 0. This is what your f1x. This is what your f2x. Okay. So f1 cos alpha minus f2 cos beta. F2 cos beta equals to 0. You got one equation, and this is what how we can get the sum of x components. Similarly, y components. So this is what sum of fy equals to 0. That means f1y plus f2y plus f3y equals to 0. Then you may ask me why you are not taking f3 here, because there is no x component of f3. Okay, so f1y is what? F1y is f1 sin alpha plus f2 sin beta plus f3, but f3 is along negative y-axis, so what you have to do, you have to take f3 as negative, so equals to 0. Okay, so you got two equations. So like this, they may give alpha, beta, or they may ask you to find f1, f2, they may give f3, f1, f2, and they may ask you to calculate sine, what is alpha, beta, like that. They may ask angle, or they may ask forces. So with the help of these two equations, what we can do, we can solve, we can get the unknown quantities. Okay. Suppose if there is some rigid support and there is a rope, so a mass is connected over here. Okay. So mass is say of 5 kg. Now how we can, if this to be in equilibrium, if this should not move down or up, so what is required? What is the downward force? F1 is mass into acceleration due to gravity, that is 5 into 10, that is what 50 Newton force is there downward. What is upward force? Upward force is what? Tension. Okay, so if sum of forces is 0, then it is said to be equal. What are the sum of forces? One is tension plus another is F1. Okay, so that is equals to 0. So what is this tension is only what? F2. Okay, so tension should be equals to what? Negative of F1. So tension should be equals to minus 50, or the magnitude of tension should be what? It should be what? 50 Newton of forces. So then we can say that this is in equilibrium. Okay, or suppose two mass is connected over here. Say some mass is connecting here. Okay. So a mass is connected whose say it is of some 2 kg. Okay. So because of this mass, there is a tension in this string. Say it is T1 and this side tension is say T2. So it is making say some 45 degree over here, and here also say from 45 degree. Now if this is to be in equilibrium, what are the tension T1 and T2? What are T1 and T2? So that body is in equilibrium. So that body is in equilibrium. So how we can calculate equilibrium? So now we have to resolve. What is the situation? Situation is like this. Say this is T1 and this is what? T2. Okay. So downward is what? Downward is 2 into 10. That is what? 20 Newton. And if this is 45, this angle is going to be what? 45. This angle is going to be what? 45. Okay. So this is also say 45. This angle is 45. and this angle is what, 45. Okay, so now along the y, and this is what along x dash, y dash. Okay, so now take x component. X component is what? It is what after t2. So x component is t2 cos 45. Y component is t2 sin 45. Here t1 cos 45 but negative, and t1 sin 45. Okay, so add them. So along x components, so x components will become what? t2 cos 45 minus t1 sin 45 equals to 0. So cos 45 is 1 by root 2, so this will become t2 1 by root 2 t2 minus 1 by root 2 t1 equals to 0. That's all. Sin 45 is also root 2, cos 45 is also root 2. So what will happen? Root 2 will go on this side. It will become finally t2 minus t1 equals to 0. So you got one equation, that is t2 minus t1 equals to 0. Similarly, you can apply for the y components also. Okay. So for y components, what you can apply? For y components you can apply here. So t1 sin 45 plus t2 sin 45. One more is there, that is downward, that is minus 20. Minus 20 equals to 0. Okay. So sin 45 means 1 by root 2 t1 plus 1 by root 2 t2. This will become 20. So equals to 20. So t1 plus t2 equals to 20 root 2. t1 plus t2 equals to 20 root 2. So you got two equations. From these two equations, obviously you can get the t1 and t2. That's all. So what is that? That equation is t2 minus t1 is equals to 0. That means you can substitute t1 equals to t2. T1 equals to t2. It means that t1 equals to t2. So if t1 equals to 2, I can write as 2 t1 equals to 20 root 2, because t1 equals to t2. Because t1 equals to t2, I am taking t2 as t1. So t1 is what? T1 is 10 root 2. Then what about t2? T2 is also 10 root 2, because t1 equals to t2. So this will become what? Sum will become again 20 root 2. Okay. So like that, they may ask you to calculate tensions, or they may ask you to calculate what is that angle made with the horizontal, whatever. So let me take an example from your NCERT, example number 5.6. Okay. NCERT book 5.6. What is given is, there is a say some rigid, suppose they hang some mass over here, mass of 6 kg, and it is of it is of 2 meter long. It is of 2 meter long. Okay. So what they are saying, at the middle of this one, they will apply some force. Say it is of some 50 Newton of force they will apply. Okay. So if they apply some 50 Newton of force, what will happen? Obviously, this string will come over here. So when they apply the force, what will happen? This will come on this side. Okay. Because some 50 Newton force is acting here. So here downward, what is there? Some mass is there of say 6 kg. Okay. What they are asking? What is the angle made with vertical? They are asking this angle. When you apply some force, it will move on this side. So how much angle it will make with the vertical? This they are asking. So how we can calculate this one? Okay. So if this is angle theta, obviously this is also going to be theta. So because of that, what will happen? Tension will develop. Say it is say some T1. Okay. Or simply you can take it as T. And here what is the downward force? Downward force is some 60 Newton. Okay. 6 into 10, it is 60 Newton. So here some 50 is there. Yeah. So what is its component? Its component here is T cos theta, and here its component is T sin theta. So alright, equations. What you have to do? We have to do sum of fx is equals to 0. Sum of fx. This side 50 is there. So this side minus of t sin theta, because negative, so minus of t sin theta equals to 0. Okay, so you can write as t sin theta equals to 50. Okay, so you got this as 1. So similarly you can equate sum of fy equals to 0. Sum of fy equals to 0. So fy is what is the upward? Upward is t cos theta equals to plus, it is negative, so minus 60. Minus 60 equals to, say, is 0. So what you can write? You can write as t cos theta equals to 60. It is what equation number 2. Now you can do equation 1 by 2. Equation 1 divided by 2. T sin theta divided by t cos theta equals to 50 divided by 60. 50 by 60. So what will happen? T will get cancelled. This one will get cancelled. Sin theta by cos theta will be what? Tan theta equals to 5 by 6. So theta equals to tan inverse of 5 by 6. Okay. So this is what how we can find that angle. So that is going to be tan inverse of 5 by 6. Okay. So don't get confused here. In textbook they must have taken here T1 and here T2. Not required. T2 is equals to what? T2 is equals to 60 Newton. Okay. That is why I am not taking T1 and T2 just not to make you some confusion. Okay. Directly you can take it as what 60, because here tension is there, here tension is there. So if this is the equilibrium, T is equals to 60. If T is equals to 60, obviously this will also become what? This will also become T only. So this is also becomes what? That also becomes 60. Okay, so that is why you can directly take T only, or you can go with as according to NCERT book. So T1 and T2 you can take separately also. Okay, but finally what will happen? T2 will become equals to 60 only. So directly also you can take. Take another interesting example. Say some rigid support is there on both sides. A mass is connected over here, and it is pulled on this side. So this is connected here, and some mass of say some 10 kg is connected over here. Okay. So what they are asking is find tension in all three ropes. Say this is A, this is B, and this is C. Find tension in A, B, and C cords of rope. Okay. So in these three cases, you have to find tensions. This is what tension TA, TB, and TC. Okay. So let me draw this one here. So they have to give angle also. This is what 45 degree. Okay. So if that is 45 degrees, so what is the diagram? Diagram is going to be something like this. Okay. See here. Here mass is there of 10 kg. Let me see. This is 45 means this angle is also going to be what? 45. So that is why along x I will take it as 45. So x is, so I will take it as 45, and this is what the y, and this side it is minus x. So here downward is what? 10 into 10. That is somehow 100 Newton. So here tension is there. This is what TC. So this is what TC only. So TC is equals to what? 100. So TC is equals to 100 Newton. So that is why here it is what? 100 Newton. So you got TC. Suddenly you got TC. TC equals to 100. So now this is what TB. So what you can write here? TB cos 45. Here TB sin 45. So what is this one? This is nothing but this is TA, not TB. This is what TA. So this is what TA. So this side it is TB. So TB no components, you can write as it is. So what you can write? Equate x value. So what is x? TA cos fx equals to 0. Sum of fx equals to 0. So TA cos 45. This side minus TB equals to 0. Okay, so you got one equation. Similarly, TB sin 45, TB sin 45 minus TC equals to 0. You got second equation. Okay, so we can get TB from this equation because you already know TC. TC equals to 100. You already got that value. from this situation. So TB sin 45 equals to TC. What is TB sin 45? Sin 45 is 1 by root 2. So TC is what? TC is 100. So TB is equals to 100 root 2. TB is equals to 100 root 2. So from with that of this one you can find TA. So TA cos 45 minus TB equals to 0. That means TA cos 45 equals to TB cos 45. Sorry, just TB. Okay. So TA, what is cos 45? 1 by root 2. What is TB? TB is 100 root 2. 100 root 2. So TA equals to 100. Root 2 will become what? 2. So TA is equals to what? 200. So what you got? You got TA equals to 200 Newton, TB equals to 100 root 2 Newton, and TC equals to 100 Newton. Okay. So these are the what tensions in 3 cords. Okay. In 3 cords, the here tension is TB, here tension is T. Okay. So like this you can find the tension values